Now, compositions is basically when you have one function and you are inserting that function into another function. That's what a composition is. So, compositions are normally denoted as three different ways. There's three different ways you can write it. Either f of g, there's like an O between an f and a g, the two functions. Now, if I was to write this myself, normally you would write O as being like smaller than the f and the g. And you read this as f of. Now, if after that notation they do not have anything, it's a blank, it means that you can assume that your input, your initial input that you're inputting first is x. And this parentheses with a number or a variable inside is your initial input. It is what you're inputting into your first function, which is, and another way to write it is as f parentheses g parentheses x. It means the exact same thing. All of these, all three of these mean f of g of x. And like I said, the very last parentheses is your input. Same thing with this notation. The innermost parentheses, what is inside that, is your initial input. And you're inputting it, whoops, you're inputting it into the very next letter. So if my initial input here is x, you're inputting x into the letter that's right in front of it, g. And then you're taking that, whatever you get for g of x, and you're inputting it into f of x. So this is my favorite function or my favorite notation for compound, because it tells you exactly what's going on. You look at the innermost parentheses and you work out. So let's go ahead and look at our what is called mapping notation. Mapping. Now we're not really going to go too in depth on this because we have notation pre-calc. You did, or you should have been introduced to it in algebra 1, whether or not you remember, I don't know. Now, map notation is just a visual representation of what's happening for your function. On the left, the leftmost oval is always going to be your initial input. So in this example, let's show you guys g of x, meaning our initial input, our innermost parentheses is x. Then after x, the next letter outside of x is f, meaning we are taking x and we're inputting it into f. So we're mapping x into f and we're outputting f of x, or your y value. Yes, that's fine. Okay. Then your next letter after f is g, meaning you're taking what you got for f of x and you're using it like it's the input into g of x. So you're mapping whatever f of x was into g and you're getting g of x. Let's try a quick little example. I'm just going to make up, now you'll never have to make up these numbers like I am, but I'm just going to make up numbers here and I'm going to show you what a mapping could look like, and then we'll do a quick little example. So I'm just looking up some random numbers. Again, this is not what you're going to have to do. This is just some random number. Uh, okay. So mapping notation will give you these numbers like this, and then little arrows for which input gives you which output. So I'm just going to draw some random arrows. You will never be asked to draw random arrows. We'll give you the arrows. Okay. So in this example, let's ask the question, um, what is P of F of 4? So remember, the innermost parentheses are your initial input. So in the leftmost oval, we are inputting 4. So I'm looking at 4 and I'm following the arrow. When I input 4, my f of x value is 3. And when I take f of x and input it into t, my output is negative 11. Meaning g of f of 4 is equal to negative 11. And you're done. Mapping notes can look really, really complicated. It's not. It's literally just following arrows and looking at a diagram. Are there any questions on mapping notation? Okay. So now let's do what we're mainly going to be doing in pre-calc, which is finding compositions of grades. So here it wants us to do two things in this example. It wants us to find f of g, and it also wants us to find g of f. So we're doing two separate. Let's first do f of g. This is in the other notation, like we were saying, f parentheses, g parentheses. And remember, if there is a set of parentheses after your second function, it means your initial input is x, which is great for us because they have already input x into g of x for us. That's the input. So what this means is we're taking all that g of x is and we're inputting it into the next letter, our next function f. So we're taking the square root of x, and wherever we see an x in f of x, we're instead writing the square root of x. Why can I not cross this? There we go. So I'm going to write down all of f of x, but I'm not going to write down the because I have a different input. I'm now instead inputting g of x. So I'm going to have, oh, those were too big. Instead of writing x, I'm instead inputting g of x, which is the square root of x. And then all you have to do from here is simplify. So how can this be simplified? Yes, they are opposite operations. The square and the square root are opposite operations. They cancel each other out, leaving us with just x there. So the composition f of g simplifies down to just x minus 1. That is the composition. You all that g of x is and input it into f of x. So now we're going to go the other way. Now we're going to do f, which is g parentheses, parentheses, and our initial input is x. meaning I'm taking all that f of x is because x is already inputted into f of x for us. So you take all that f of x is and input it into g of x. So you're going to be writing down g of x, but instead of writing the x, you're going to replace it with f of x. So you're taking all of f of x, and wherever you've seen x and g of x, you're instead writing x squared. Now, can this be simplified? Oh, so because you have two terms that are being subtracted, you cannot separate the x from the negative one. You can't treat them like they're two separate things. This is the same concept as if you had this. Can you just square both of these and get this? Is that how squaring works? No. What you would have to do is here you would have to multiply x plus 2 times x plus 2. You cannot, don't write this because you can't do it. You cannot put this into the square root of x minus the square root of 1 for the same exact reasons as you could just distribute the two. You cannot find the square root of these two separate terms. It wouldn't actually be the square root of x squared minus 1. So instead, this is as simplified as it gets, and you're done there. Okay. So now, thumbs up if you would like another example. Thumbs down if you're good to go. Okay, yeah. Okay. Thumbs up it is. All right. So now we're doing the exact same thing. First, we're doing f of g, but then it wants us to do f of f, which actually isn't any more complicated. First, though, we're going to do f of g, which is f of g of x, meaning we're taking all of g of x, and wherever we see an x in f of x, we're instead writing x squared minus 4. And then we simplify because when I input g of x into f of x had nothing done to it, it means that these parentheses really didn't even need to be there, right? Nothing's being done to those parentheses. So instead, I can just go ahead and immediately combine like terms. So I just need to combine negative 4 and 7. And I get 3. And you're done. Then we're going to do f of x, which is where you will take all the f of x, so x plus 7, you're taking all of that, and you are inputting it in for x back into f of x. So I'm going to write f of x, what f of x is, but I'm not going to write that initial x. I'm going to put a sign. And then instead of x, I'm going to write all that f of x is. Again, another. So you're inputting f of x back into itself. And you combine like 7 and 7, and you get. Are there any questions here? Okay, so now we are going to be doing compositions, but with different inputs other than X. So remember I said that if you don't have a set of parentheses after your composition notation, it means that your initial input is X. But if you do have another set of parentheses with a different number, it means that the number inside is your initial input. So we are going to be first doing f of g of 3. Whoops, let's do purple. F of g of 3, meaning the first thing we have to input, we're actually doing an extra step that we didn't do before, because before they had already input X for us and we didn't have to input X. This time though, we're having to do an initial input other than X, so we have another input we have to find. So first thing I need to do is figure out what g of x is equal to when x is 3. So I'm going to do g of 3. I need to figure out what g of x is equal to when x is 3. So instead of writing x in g of x, I'm now writing 3. I'm inputting 3. And what is this? I almost said square root. What is the absolute value of 3 minus 7? 4. Yes, 4, right? Absolute value means you're finding the size or the magnitude of the number inside of the absolute value. So 3 minus 7 is negative 4. The absolute value or size of negative 4 is 4. And 4 plus 2 is just, why did I change the order? 4 plus 2 is just 6. So now we know g of 3 is equal to 6. So 6 is what we are inputting into the next letter in our composition notation, F. So we are now taking 6, and in f of x, wherever we see an x, we are instead writing 6. So 6 squared is 36, minus 5, 31. So that, there are no letters in front of f, so I know I'm done inputting. That is my final output. My final output is 1, and I'm done. I have found all G of 31. Any questions on composition? Thumbs up if you want to do another one. Thumbs down if I can do it. Thank you, you like 4 people. I will do another one. Okay. So now I'm inputting negative 2 first. My initial input is negative 2. I'm finding b of negative 2. So I'm working the other way now. I'm taking negative 2 and inputting it into f of x first. So I have negative 2 I'm writing instead of x in f of x. Then negative 2 squared is just 4, minus 5 is negative 1. So this ends up equaling negative 1. And I am inputting that into the next letter, g of x. I'm taking negative 1, and instead of x in g of x, I'm writing negative 1. So now I have -1 minus 7 is -8. But the absolute value of -8, which is just 8, plus 2 is 10. And then there are no letters in front of, oops, there are no letters in front of G, meaning I am done. That is my final answer. G of f of -2 is 10. Done. Are there any questions? All right. So now we are going to be doing graphing. We're going to be looking at graphs, tables and graphs, and finding composition. So this may at first seem tricky, but really it's just knowing your input and knowing your output. Whenever you're given a graph, any graph, and being asked to find compositions, you always must create a table. Always, always, always. Even if they don't give you one, like on this part B, they don't give you a table to fill in, you should still create a table. It helps you keep your numbers straight. So on part A here, we are given a table for g of x, and then we're given a graph of x. And looking at this table, this blank table, it wants us to find our g of x, meaning initial input is x. We're taking x, and we're inputting into g, and then whatever we get for g of x, we're inputting into f of x. So my initial input is x. Whenever you have your initial input of x in that first table, you're just going to take those x values and copy them down. -3, 0, 2, 5. Those are your initial inputs. They don't change. So you're writing down, you're copying down whatever was input first. And then you're working with each separate x at a time. So first, if I'm looking at -3, my g of x output is 2. So then what you do, this is like your input into f of x. This is like your new x value. New x for f of x. You're taking 2 and you're finding 2 on the x-axis for f of x. So you're looking for 2 and you're finding points that have the x value. So down there, the only point that has 2 as the x value is that point down there, outputting the f of x value of -5. I don't know what that is. Okay, so then you repeat. Now I'm working on the second x, 0. When I have 0 as your initial x value, the g of x output is 5, and you're treating that like your new x for f of x. You're finding 5 on the x-axis, and you're looking for the point that has 5 as the x value, and that point has a y value of -1. So your f of x value is -1. And then you do it again. Next, x value is 2. When x is 2, g of x is 0. Treat that like your new x value on f of x. So I'm looking for 0 on the x-axis, and you find a point that has 0 as the x value, and at that point, the y value is -2. Without me walking you through it, what is the f of g of x value when your initial input is 5? So let's see. Yes, 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 yes. Perfect. What about when it's 9? What is your output? That's exactly. Any questions on this graph? Okay. So now we're doing the same thing, except they give us, instead of a table and a graph, they give us two graphs, and then they want composition. But like I said, anytime you have graphs and compositions, you should create a table to keep your values free. So we are going to have a table, and it's going to have three columns. One for the initial input, x, one column for whatever you get from that input in g of x, and then your last column for, I kind of wrote this kind of big, for f of g of x. So we're working from the inside of these parentheses outward. So we're taking x, inputting it into g of x, and then inputting it into f of x. Meaning we should, oh God, stop. Meaning we should be first looking at this g of x graph. So the x values on that g of x are our initial input. Those are the values we're putting in the first column, x column. So what I'm going to do is I'm just going to look at all these points, and I'm going to write down their coordinates. So, and you always go left to right, from least x value to greatest x value. So my least point, my least x value there is this point, which is at 0, -2. And then you write down the next point, which is 1, 2. And then you have 2, -4. Stop. And then you have 3, 0. And lastly, you have 5, -1. And then, remember, just like last time with the table and then the graph, we're taking the outputs that g of x gave us and treating them like they are the x values on our graph, our next graph, which is f of x. So we're taking all of these g of x's and we're treating them like they're the x values. So I'm looking on this second graph, this x graph, when your x value is first -2, what is your y value, your output? I don't know if that's a zero. Okay, yes, 0. Perfect, right? When your x value is 2, your output is 0. When your x value is 2, what is your f of x value? Yeah, 4. When your x value is -4, what do you get? So you're looking for -4 on the x-axis. Yeah, -4 on the x-axis gives you this point, which has a y value of 3. What about when your x value is 0? Yes, 1. And when your x value is -1? Yeah. So now I finished my table, right? I found the final outputs f of g of x. Now I just have to graph these. To graph, you're using the initial x input as your x value. You're still using this first column as your x value, but you're now using the last column as your y value. So again, you're now going to be graphing g of x, your x values, and this last column y, because then that was graphing f of x. Instead, you're using the initial x values and your compositions that you have. So my first point I'll be graphing is 0, 0. I'm drawing them big. I want them clear. And then your next point is 1, 4. And then your next point is 2, 3. And then you have 3, 1. And lastly, you have 5, -3. And you have now graph the composition f of g. Are there any questions on these graphs? No, we're not in here yet. You're saying like taking x values, inputting them into an equation, then after you graph whatever you get. No. Okay. We are again going to be looking at two graphs and then graphing the composition on a separate graph. So they have so nicely created a table for us to fill out. So remember, whenever you're doing graphing of compositions, you want to create that table. And we are taking x and inputting it into f of x, and then we're taking whatever that output gives us and inputting it into g of x. So we are looking at f of x first. So what I'm going to do is I'm just going to write down each of those perfect points. I have, and you always go left to right, least x value to greatest x value. So you have -4, 2, you have -1, 2, you have 0, 0, you have 1, 3, 2, 4, 3, 3, 4, 0, and way down there, 5, -5. Then our next letter after F, in front of F is G, so I'm taking all of these f of x values and inputting them into g of x. So you're treating them like they are your new x values, your new inputs. So when your x value is 2, your g of x value is -1. When your x, oh, that's the same thing, -1. When your x value is 0, your g of x value or y value is 1. When your x value is 3, oh, I hate guessing. But here it looks like that is going to be -0.66, which isn't really a guess because you go up 1 over 3. So these, it should be going up a third each time. So this is going to be -0.66. This is going to be -0.33. So, oh, and that's our next one, -0.33 repeating. And then again, we have when x is 3, your f of x value or your g of x value is -0.66. And when your f of x value is 0, your g of x value is 1. And -5 is not on that g of x graph, so we can't graph that. So now we go ahead and we're going to graph the initial inputs, your x values, and your composition g of f of x as your y values. So we have -4, -1. We have -1, -1. We have 0, 1. Then we have 1, -0.66. And 1 or 2, -0.33. And 3, -0.66. And 4, 1. And then going left to right, we just connect those points. And that's what we end up with.